Hello, knowledge seekers! Welcome to Remedial Tutorial Academy. In this video, we're going to talk about the difference between prime numbers and composite numbers. And also, we're going to go over prime factorization, how to factor large numbers into small numbers that are composed of prime numbers. So let's begin. So first, what is the difference between a prime number and a composite number? A prime number, like 5, can be broken down into two factors, 1 and itself. A composite number, like 8, can be broken up into 2 prime numbers, or more. It could be 3 prime numbers. You can break up 8 into 4 and 2, and 4 can be broken down into 2 and 2. So as you can see, 8 is made up of multiple prime numbers. It doesn't have to be consisted of 1. So 8 is a composite. By the way, this is known as the prime factorization of 8. If you break it down into a product of prime numbers that multiply to 8. So let me give you another example. 7 is a prime number because 7 is equal to 1 times 7. Anytime 1 is one of the factors, then this number is a prime number. If we take 10, 10 can be broken down into 2 prime numbers, one of which is not 1. So 10, you could write it as 2 times 5. If you can break it down into prime numbers that don't contain 1, then this original number 10 is a composite number. So let's make a list of all the prime numbers and the composite numbers that are out there, and also those that are neither prime or composite. 0 and 1 are neither prime or composite. 2 is the prime number. You can only break down 2 into 1 and itself. 3 is a prime number, so is 5, then 7, 11, 13, 17, and 19. The only factors that will multiply to any of these numbers is that number and 1. Composite numbers include 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and 20. Each of the composite numbers can be written as a product of factors that doesn't include 1. So 4 can be written as 2 times 2. That's the prime factorization of 4. 6 can be written as 3 times 2. As you can see, you can break it down into small numbers that doesn't include 1. If it does include 1, then it will be a prime number. All the prime numbers will have 1 as a factor, and that's the key difference that separates prime numbers from composite numbers. 8, we said it's 2 times 2 times 2. 9, you can write it as 3 times 3. 10 is 5 times 2. 12, it's 3 times 4, and 4 can be broken down into 2 times 2. 14 is 7 times 2. 15 is 5 times 3, and you get the point. All of the composite numbers can be broken down into prime numbers that don't contain 1. All the prime numbers can be broken down into factors where 1 is included. It's going to be 1 times itself. That makes it prime. And just remember, 0 and 1 are considered not to be prime or composite numbers. Now let's talk about writing the prime factorization of larger numbers. What is the prime factorization of 50? Now you can use the factor tree to help you out in this case. So first, let's divide 50 by the smallest prime number that we know of, which is 2. 50 added 2 is 25. Now once you have a prime number, highlight it or circle it, because you're going to use that when writing the prime factorization of 50. 25 is a composite number, and you could break it down into 5 times 5, both of which are prime numbers. When you have no more composite numbers, then you can make a list. You can write the prime factorization of 50. So the prime factorization of 50 is 2 times 5 times 5. You want to write 50 as a product of the factors of all the prime numbers that compose it. Now, sometimes in your homework, you may be asked to write the prime factorization using exponents. Because we have 2 5s, we can write it as 5 squared. So you can express the prime factorization of 50 like this. You could say it's 2 times 5 squared, since we have 2 5s. So you can leave the answer like this, or you can write it this way. But for the sake of practice, I'm going to write it both ways. So now it's your turn. Write the prime factorization of 120. Feel free to pause the video if you want to. So first, let's divide 120 by 2. 120 divided by 2 is 60. Now 60 is an even number, which means that it's divisible by 2. 60 is 30. 30 is also an even number, so let's divide it by 2. That's going to give us 15. And 15 is a composite number that we're familiar with. It's 5 times 3. So these are all the prime numbers that multiply to 120. So F, not 15, but 120 is 2 times 2 times 2 times 3 times 5 in ascending order. Now to write it using exponents, we're going to simplify these three 2's. We're going to write it as 2 to the third power and then times 3 times 5. So that's the prime factorization of 120 using exponents. Now let's work on another example. Let's write the prime factorization of 280. So feel free to pause the video if you want to. So 280 divided by 2 is 140. And if we divide that by 2, that will give us 70. And if we divide 70 by 2, that's 35. 35 has a 5 at the end, so it's divisible by 5. 35 divided by 5 is 7. So these are all the prime numbers that compose 280, or 280 consists of those prime numbers. So 280 is 2 times 2 times 2 times 5 times 7. So we can write it as 2 to the third power times 5 times 7. Here's another one that you could work on for the sake of practice. 540. Go ahead and write the prime factorization of 540 using the factor tree method. So since it has a 0 in front, we know it's even. Let's divide it by 2. 540 divided by 2 is 270. And then we could divide that by 2. That's going to be 135. Now 135 is not an even number, it's an odd number. And it ends in 5, so we can divide that by 5. So 135 divided by 5 is 27. 27 we could divide it by 3. 27 divided by 3 is 9. And 9 divided by 3 is 3. So 9 is 3 times 3. So these are all the prime numbers that multiply to 540. So to write it in ascending order, we can say that 540 is 2 times 2 times 3 times 3 times 3 times 5. So now let's write it using exponents. So we have two 2's.
Two 2's. So we can write 540 as 2 to the power of 2 times, and then there are three 3's. So times 3 to the third power, and then times 5. So this is the prime factorization of 540 using exponents. Here's another example. It's a much larger number, 10,800. Go ahead and try that one. So this might take some more work. Let's divide it by 2. Half of 10 is 5. Half of 8 is 4. So half of 10,800 is 5,400. If we divide that by 2, 54 divided by 2 is 27. So this is going to be 2,700. And then if we divide that by 2, this is going to be 1,350. And we could divide 1,350 by 2 due to the 0 at the end. And that's going to be 675. Now this ends with a 5, so that means it's divisible by 5. It's no longer even, so chances are it won't be divisible by 2 anymore. If we divide it by 5, 675 divided by 5 is 135, so there's another 5. 135 divided by 5 is 27. And let me just continue this here. 27 is 3 times 9. And 9 is 3 times 3. So let's box in all of the prime numbers that we have. So 10,800 is 2 times 2 times 2 times 2 times 3 times 3 times 3 times 5 times 5. So now let's write it using exponents. There are 4 2's that we see here. So that's 2 to the power of 4. And then we have 1, 2, 3 3's. So that's going to be 3 to the third power. And then there are 2 5's, or 5 squared. And you could test it out in your calculator. If you type in 2 to the fourth, which is 16, and then 3 to the third, which is 27, and 5 squared, which is 25. If you multiply these three numbers, you should get 10,800. I'm going to type it in just to make sure. And that's exactly what I got. So you can always check your work if you want to. So this is the prime factorization of 10,800 using exponents. Thanks for watching the video. To get more math and physics courses, subscribe to the channel and click notification button.